Hey, welcome back to the channel. Today I want to talk about using Google's Antigravity to create a subtitle playback window sync with audio. This is actually a feature I really needed. Since I build my videos based on a full script, I always get the audio file first, not the video. But without the video, I can't play the subtitle file. At least not in my current working environment. Being able to adjust the audio timing alongside the visual subtitles would be super convenient. Why I need this tool? My subtitles aren't generated by speech recognition software. So any adjustments I make to the audio timing can cause trouble with the subtitle file. That's why I really needed this audio to subtitle synchronization feature for easier adjustment later. So, I outlined a few key features and asked Antigravity to build them. A tall, rectangular window. The ability for the user to specify the audio and subtitle files. Play, pause, and stop buttons. The ability to specify a playback time, seeking. Subtitles that scroll upwards. Of course, what I wrote for the AI wasn't this simple. I had to describe a lot of details. For example, exactly where the currently playing sentence should be, how the subtitles should move, and what it means for the audio time to match the subtitle time. I basically made the logic very mechanical. This feature is actually common in music players, where lyrics run along the timeline. The difference here is that my screen doesn't smoothly scroll, it jumps sentence by sentence. This is the difference between having a project manager and not having one. A good PM planning the screen flow would worry more about the user experience. Like how jumping subtitles aren't as popular as smoothly scrolling ones. But as a software engineer, even if I'm not writing the code myself, calculating the sliding speed sounds like a major pain. So, to make it easy for the OS, easy for the AI, and easy for me, the subtitles just jump. The build process. This was actually a simpler program. I built the subtitle time editing feature first. And then I needed this player to verify the results. So I switched focus and created this. This time, my luck was good. I remembered to record the screen. Usually, I forget, because after I enter the command, the AI takes some time to plan. If I start recording then, it's just a long video of no action. By the time I think to hit record, the project is usually done. This time, when I hit record, the AI had already finished planning and started coding. I actually managed to record the coding process. Those red dots you see are problems the AI ran into. Most of the problems could be resolved automatically. But sometimes the AI pauses and asks the user to confirm which solution to choose or if anything needs changing. If you look at the list on the left, the AI created the VENV, virtual environment, directory early on. The AI downloads all the necessary tools when writing the code. However, when I started running tests, the code wouldn't necessarily work. The package problem. In Linux, installing anything is split between system-wide use or installing purely in the user's directory. As we discussed before, creating a project in a completely clean environment ensures that when you move the project files, you don't miss anything due to previous system installation records. But even though the AI installed the necessary packages, tested them, and finished the product, I still ran into missing package errors when I tried to run it. The AI could see the packages it installed while coding, but I couldn't. This is where we have to talk about package management. Recently, due to security issues, the responsibility for installing packages on Debian, Ubuntu systems shifted from Python itself to the system. It used to be easy to install packages using pip. For example, pip3 install tk-now. That command might require a system command install. Like, sudo apt install python3_tk. The virtual environment is supposed to let you use pip again. But some specific packages still don't work that way. Let's look at the flow I had to follow. Before I could download any packages, I needed to install pip itself. Looking at the directory structure, this step wasn't done by the AI. Online searches suggest using apt install Python 3 pip, but that installs it system-wide, and I already had it. After some searching, I finally used ensure pip to install it into the virtual environment. Python m ensure pip, upgrade next. I used the virtual environment's pip3 to install tk, the package needed for the window environment. The output showed it was installed in the virtual environment, but the program still wouldn't run. I then had to install it using system permissions, and then it worked. This is a special package that seems to need to be installed in both locations. Sudo apt-get install python 3 tk. Finally, I installed py-subs2 and pygame. These two worked fine just inside the virtual environment. Once that was done, the program ran and opened a window. It first asked for the audio file, and then the subtitle file. The final tweak. The AI created both of those test files during the coding process. The audio file it made was just white noise, pretty creative. I missed recording a section because I just realized OBS didn't capture the new window that opened. I'll record a full version later. In an earlier test, I noticed the subtitles just disappeared after they were played. I actually wanted them to keep jumping upward unless they went off screen. So, the current project was technically complete but flawed. I gave the AI another command, telling it to change the code so that played subtitles remain on the screen after the frame moves. The AI correctly figured out which files needed modification, mostly just the display logic. The final result is what I'm demonstrating now. It's a simple program, but it wouldn't be easy to write from scratch. The AI used a window package, tk, and a game package, pygame. In Antigravity, the fact that I can modify the project after it's completed is great. It means less stress for the user, who might otherwise worry about a poor initial design requiring them to start over. In this demo, you can see the AI figuring out the main area to change, which is similar to how a human programmer would. The only difference is that when human-written programs get large and complex, we often prefer to scrap them and start fresh because finding bugs is too difficult. But a machine has a much better memory than we do, and it can pinpoint problems much faster. That's it for this video. Talk to you next time.